Good morning, I'm Stephen Davison, and I'm in the Digital Library Development Group at Caltech, and I'm here with my colleague Tom Morell and the other three co-authors not with us today, unfortunately. So the topic of our of the talk that we're going to give today is building tools and workflows around existing repository systems at Caltech. Hopefully that our experience and our strategies and the tools that we're building will provide you with some food for thought and strategies for your own for your own repository development. Put a number of themes up here on the board: constraints and opportunities. Caltech is a very small institution with a very large research footprint. We have only 300 faculty, only about 2,200 students, undergraduates and graduate students, but the amount of research that comes out of Caltech is massive. We manage the JPL, Jet Propulsion Laboratory, the Gravitational Wave Laboratory, LIGO, a worldwide network of observatories. So a very small team has to provide services for a very large research footprint. And we have to work within those resources. So we're going to be talking about data flow and the workflow around our repositories and the way we are building connections between our various repository systems. So I'll give a little bit of an introduction. I've talked about the institutional context that we're working in, talk a bit about the various repository systems that we manage, a couple of seed problems that were the instigation of our current work, the problems we were trying to solve and the direction that we've taken. And then Tom's going to actually talk about the tools we've built, demonstrate those tools, talk a little bit about the future directions, that we have future development directions. And then I'll wrap up with some principles and some lessons learned. So, as I said, we work with very limited resources. We have to match our needs across a variety of different systems, our staff skills matching those systems, and we have to manage multiple workflows as we manage multiple repositories and work with multiple metadata standards. The response to this sort of environment, typically, and I'm sure it's true in your institution also, is that you focus on solving particular needs. You focus with specific activities, and you have staff specialization. So if you have a specific type of repository, someone has to become a specialist, either a developer or a manager or a metadata expert in that particular repository system. And typically, we, as many other institutions, have developed a number of different repository solutions for different problems. We have an institutional repository, an extraordinarily successful institutional repository for published papers, a digital library system for digital objects, a research data repository, and increasingly management of born digital materials in the archives. So in our particular environment, we've used ePrints for a number of years, over a decade. It's over 60,000 publications. It has over 10 million downloads so far, so very successful repository system. Our digital library is Islandora. We are digitizing complete collections. So we've got a couple of 100,000 images of manuscript pages, plus a lot of photographs in our Islandora repository. We have a new research data repository that Tom talked about yesterday, which is based on Invenio 3, and it was built for us by a CERN spin-off called TIND, who are based in Norway. And we are starting to build out born digital collections in the archives, and for that we have a number of different tools that we are working with, EPAD, Archivematica, et cetera, and managing the data, archives data, using archive space. So, managing all of these with a small team has been very difficult. So we had a couple of seed problems, a couple of problems we had to solve. One was we, in the past, have built services around ePrints. ePrints was our premier repository. We needed to build lists of recent publications out of ePrints. And what we would have done formally would have been to build directly against the ePrints repository. We decided not to do that. We decided to actually use the ePrints API, which is very mature, very good, very easy to work with, and to create a data feed based on the API. At the same time, we were working with archives on moving all of their data out of their management data out of a homegrown system based on Cold Fusion and FileMaker Pro into archive space. And they needed to expose all of that on the website, have a search and browse functionality on the website. Again, what we could have done, what we would have done in the past, is to build, in this case, to use the public interface of archive space, to skin archive space. We hated that. It's not very nice. It gives you very restricted functionality. You can't really do much except skin it. So we decided to, again, use the archive space API. And then it occurred to us that what we were doing was actually solving two completely different problems with exactly the same solution, which is to leverage the APIs. And so we have started to generalize that solution across all of our repository systems. So Tom is now going to introduce you to the tools and techniques that we've been developing to do that.
So from the entire development group at Caltech, we've been developing a set of what it would describe as really kind of basic management tools that work primarily on the command line for dealing with repository-like data. So we have Dataset, which is a very simple package. All these packages are available on the library GitHub page, so you can look at them and download them. But Dataset basically manages JSON documents on disk. So you can give Dataset a set of JSON documents, it stores it for you. And then you can either store that locally on disk, or we've got a plugin where that'll send it over to S3 on AWS. We've also got a package called Data Tools, which are really slick little utilities for working with data. So if you're working with CSV files or JSON or Excel documents or CSV documents, you can easily extract bits of CSV documents out, transform stuff between different formats. It's a very nice kind of general package for dealing with basically data sets. So this forms the base of how we're going to be storing and managing this data outside of any given repository system. So from each of our kind of four systems, we have little utilities that harvest that utilize the APIs to extract out data. So we have a little package called Kate, which uses the archive space API to harvest all the data that's present in archive space. We have a little package called EP, which uses the ePrint API to harvest all of that content out, transform it into JSON, and store it in Dataset. And for our Invenio product, we have this Caltech data _feeds package, or really it's a Python script that uses the API, harvests out the metadata, and sends it into Dataset. So basically, we're harvesting all this metadata out, and we're storing it on what is effectively S3. So it's a very, very lightweight system for effectively managing the metadata. What we can do with that. Oh, and we're going to be doing the same thing for our Islandora using OII and PMH. So in this document, or in this diagram, everything that I have with a solid line is code that exists. Everything with a dashed line is stuff that's in the plan. So once we have that data collected, we can then export this out to stuff that can be made available to the public. So we have MakePage, which is a nice lightweight processor for making static websites. So this populates our feeds.library.caltech.edu page. That's a public resource. You can go and browse that now, which has data that we have in our library systems. It also processes the content that's on the archives website, and I'll show you this in a little bit more detail just in a couple slides. Then we have the library website. That's a Drupal-based web service, and that pulls data into the website from our feeds. So we present this data as open data in standard formats, and then we can process that out into the library website. We can then also pull in external data. So we're currently harvesting everything that we can get from the public ORCID API. We have a little ORCID tool package that automates some of the ORCID API calls. And we're planning on pulling more content in from Crossref and FundRef. We can also then use batch update tools to refeed some of the metadata across our different repository systems. And then we can also use a very similar approach for doing backup and preservation. So we've been in the process of moving a lot of the data from our repositories onto the digital preservation network. And so we've been using basically Baggett packages for both ePrints and Islandora. And on our data repository, we're storing all of this content locally at Caltech. And so we've got a little package called Caltech Data Read, which again uses the APIs to process all that data together. So again, because we're using kind of an API-based management model for our repositories, we can both get data in and get data out of all the systems and then do stuff with it. So I'll show you a couple of those applications now. So we're going to start by looking at the Caltech Library Feeds website. So our seed problem, and this is all live, you can take a look at it now, was we wanted to get the recent articles. So not just the latest stuff that was added to the repository, but what was published most recently. So we got that listing, and we pull that now into our main library webpage. So this kind of new in Caltech authors box is being run from our feeds data source. So we present that in the kind of regular HTML page if people are browsing it. We also present it as a JSON file, and you'll notice that on the JSON file we actually have everything, basically everything that's present in the underlying ePrints XML record. So if somebody outside the library wants to work with more of the data that we have, we actually present them basically all the data. We also have an HTML include version, which it's going to now. We also have BibTeX. So if folks want to drag out their publications and put them in a BibTeX form, we support that. And we also support an RSS feed. So basically by grabbing all this data, we can then republish it in standard formats. The other stuff we're doing is we're showing stuff kind of via affiliation. So we have different groups on campus that have been entered into our institutional repository. So now we can generate these standard lists of here are all the publications that are associated with that group. We include that in a whole sort of different, the whole standard formats as well. So they can then go and use these things in their group websites, or they can get out a BibTeX record that they can use for their publications. We're also experimentally doing this with ORCID for kind of personal profiles. This is where we're pulling in the ORCID API. So that name we're actually not pulling from our internal system. That's actually the official name that somebody's registered with ORCID. And we give them now a listing of all their publications that we've been able to find in our system. And again, we not only give this as an HTML page, but you can also use content negotiation to give this out in a BibTeX type format. So this is basically making our data more available to the public, and we can then use this externally to do cross-repository development. So this is the other seed problem looking at the archives website. As you can see, it's a fairly standard website, all HTML pages, but when we were switching to archive states, we didn't want to have too big of a change. We wanted the website to look basically exactly as it did before the archive space transition. So we've built this search interface where you can search, you can click through, and all of this content is rendered with MakePage as static web pages with the actual metadata that's present in archive space. So it basically looks like the website used to look. So if you're looking at it, it looks the exact same it used to, but the underlying data source has changed. And this again gives us very nice flexibility to change things in the future. The demo that I'm going to do now, we have a demo repository, so you can run this on your own computer if you'd like. This is demonstrating how we can do cross-repository searching. So what we're doing now, we're harvesting a subset of our ePrints records. They're putting that into that data store on our local machine. We're now harvesting Caltech data records. It's going to the API, harvesting those JSON files, and again, putting them in our local data store. We can then index across those two collections, and then we can run a web interface, again this is on our local machine, that allows you to do searching cross repositories. So now we can do search for an author, say, and it'll pull up what are records. So we can now pull up our publication records that has that author name present. We can also pull up data records that are in the data repository. So you see down there at the bottom, we've got a Caltech data record. And this is really easy to set up. To set up the indexes, you basically just say a JSON record or a JSON file with what your indexes are, what you're going to be searching across. And you can basically build an entire search interface right on your own local machine. It's really lightweight, and like the Feeds website is running on like a nano AWS instance. So it's a very easy way to make your data about your collections that are in repositories open. You could do other searching, so you can search with nice queries where you can look at just a subset of your data. You can search within specific fields. So here we're going to look for the word galaxy, which is present both in abstracts and descriptions and titles. We're going to sort that back to just the keyword field, so we can subset. So this is based on the Bleve library. It's very powerful and very flexible, but again, it's a really lightweight and easy to use service. And we've actually used this, not only for the set of tools we've used not only for our own internal repository uses, we've used this for generating reports. So in looking at, with our librarians, looking at like ebooks and managing long title lists, you can use the same set of tools to do that type of work. So now that I've shown you kind of what we have in production, what you can see today, I'm going to talk briefly about what we're planning on doing in the future. So we really want to expose more of our repository systems to the users. And we want to primarily do that with the library website as the starting point. So instead of clicking through the library website, getting to a different repository system that looks different, we want to be able to pull some of that content out and display it to users. And we're going to be doing this via Feeds, where we can now have our data living outside the repository or pointing back to the files that are living in the repository. And we're also planning on implementing a IIIF viewer, so we can pull content that's currently in Islandora and present that in a more standard interoperable format. From my perspective as the manager of the data repository, I'm very excited about building in connections between our existing very rich publications repository and our data repository. In the initial use cases, we want to be able to connect publication records and data records with basically is supplement tags. So if somebody says, this data set is associated with this publication I've made, we want to be able to internally detect that and say, oh, this is a link. And when the publication's added to our publications repository, that metadata tag linking between the two is added automatically. So basically, if somebody, we obviously need to know that the link exists, so somebody will have to add the link into one of the repositories, but if it's added in one repository, we should be able to make the corresponding link automatically in the other repository. And basically working on this kind of metadata layer, I think will allow us to do this kind of automated metadata enrichment. The other metadata we're really excited about adding is standardizing funding information. So we have funding information currently in our publications repository and in our data repository. We'd like to standardize how we describe our funders with the kind of FundRef standard names and include that in both the repositories. We're also very excited about using Crossref event data. So this is a very new service coming out of Crossref that collects stuff like Twitter mentions, inclusions on Wikipedia. And we can pull in that metadata from Crossref, add it to our metadata store, and then display that in the local repositories to give researchers an idea of what the impact of their work might be. The other project we're working on that includes all of our repository systems are author identifiers. So we have authors in all the different repository systems, and they're not necessarily tied to a specific individual. So we really want to centralize what are the authors that are associated with Caltech, what their ORCIDs and ISNIs and other identifiers are, determine what their affiliation with Caltech is, and we're in discussions with Central IT at getting access to their data warehouse with the Caltech HR type data, and then to be able to update all those identifiers in all the different repositories. And this allows us to do kind of user-based views of their data that include, both stuff that might be in the archives, stuff that might be in the publications repository, and the data repository. So again, by using this framework, we can really build in some rich connections between all the different repository systems. And now Stephen's going to wrap up with some kind of concluding remarks.
So just to review a couple of the principles that are underlying this work. First of all, everything we're doing is API-based or harvester-based, so that we're not building end-user tools directly against the repositories. They still exist. We will use the repositories out of the box when it makes sense, but build out at the edges when that makes sense. These products are really, really, really small. They're so small they could run on a Raspberry Pi. They could be embedded in other systems. They'll run on your laptop. This is not a big framework that we're building. Everything is as simple as possible, very modular. One of the basic principles we've used is that the data all flows in one direction. Yes, we can do some batch updates, but basically these tools are expecting an input and an output. So keeping these structures and workflows simple allows us to work very efficiently with our small team. The repositories are essentially almost black boxes. We don't need to understand the repositories as much as we would if we were building directly in those environments. When we need to replace a repository, we would do that. We're trying to work in the cloud as much as possible, and we're working with vendors as much as possible. So a couple of these repositories, the Invenio repository and the Archives Space repository, are actually vendor-based. We have a vendor who are hosting those for us. And the basic principle is that this data is harvested on a continuing basis. We don't need to think about migration because we're always migrating the data out. There's a nightly extract of all of the data from the repositories, which populates the data set sort of tools. So this is an abstract of the diagram that you've been looking at, where the repositories can be replaced by other repositories. A hosted repository would learn a new API, so we could replace them as needed. But if we don't need to, ePrints meets our needs, we're going to keep ePrints. The data repository meets our needs, we're going to keep it. Archive Space is standard. That's not going anywhere anytime soon. But if the one that we might replace at some point could be Islandora. If we wanted to replace that with, say, Hydra in a box or something like that, we could do that. And as Tom said, we want to build against the data set sort of tools in a variety of ways. We have various users, researchers, collaborators, systems, harvesters, and aggregation systems, various analytical tools that could run against this. There are various things that we are working on for the campus right now. Identity management, Tom talked about, compliance assessment, value assessment. And one thing that doesn't get a lot of mention, which I think is actually quite important, is the archives institutional repository integration. As published articles, as the published corpus gets older, it becomes archival. It becomes part of the historical record. And being able to link up archival materials from the scientists who work at Caltech with their publications, I think will be a very valuable component going forward. Very quickly, why aren't we working in an environment like Hydra or some other large system? Mostly because we really, really like the components that we have. We want to keep working with them. We really understand them. And we want to build really simple, user-based, user-oriented services and feeds around those. And this is the most efficient way to do that. Migration is always going to be an issue. None of these systems are going to stay there forever. So what we have embraced is continuous change and building at the edges around these repository systems. Thank you very much.
Perfect timing for our presenters, so we have time for questions. Please wait for the microphone to come to you because this session is being broadcast.
So you're really making use of APIs from a lot of component systems. It sometimes seemed to me that the library community has not been, or the repository community has not been as progressive about exposing APIs from their systems to others in the course of doing their work. We often talk about how other systems should have better APIs. In the course of doing this, did you find out what's a good API and what is less good, or do you have words of wisdom or guidance from systems or providers of systems that you're harvesting from?
I haven't worked directly with the APIs, so I can tell you that my principal developer, Robert Doyle, thinks the ePrints API is terrific. And the real problem we had with the Archives API was that there wasn't any documentation. So it was a bit like, working in the dark, trying things, seeing if they worked or they didn't work. So I don't know if you have anything.
Yeah, and I think the Invenio API has been a similar challenge of figuring out specifically what the options are. And I think the more documentation that's available on the APIs, the easier it is for us to develop services around them. So I would echo that recommendation on documentation.
Hi, Christian Corticas from University of Queensland. You've mentioned how you're running quite a lot of these systems that have a lot of features that overlap, ePrints, Archive Space, and Video, and that you're having to maintain, host, and understand all the nuances about each one. How do you see the cost of doing that, having these multiple systems and then having to integrate them all together compared to potentially consolidating on one system where, it may not have all the features of all of the things, but is a bit less to maintain, or maybe the cost of implementing the extra 5% in that one system is cheaper?
I think that the challenge for us as a library is we have these existing systems. And so it's not just a technical question of migrating from ePrints to something else or from migrating from Islandora to something else, because we could do those types of transitions. The challenge is really with matching features. So we've had the library's worked with, say, imprints for over 10 years, and so there's a lot of kind of embedded knowledge and understanding of how that repository works. And so if we were going to make a migration because of any given benefits, it's going to be, I think, virtually impossible to actually match those features and make the users happy. So I would say if we don't have to do those migrations and we can still do development around the edges of the repository system, we can get the benefits of nicer user interface, nicer display things, without having to rip up everything that we've done for the last 10 or 15 years. Yeah. You have anything else on that?
So two of the systems that were taking up an awful lot of time were Archive Space and Islandora. And our solution to that is we outsource. So Islandora is now being hosted by Lyricist. We let them deal with it. And we're looking to outsource Islandora because we don't want to be in the business of building in the Islandora platform or maintaining it or patching stuff. We're happy to pay someone else to do it. They can do it really efficiently. If they've got 20 other customers doing the same thing, they can do it a lot more efficiently than we can. ePrints we understand, so it's more efficient. So things which it's more efficient to outsource, we'll outsource. Things where it's more efficient for us to keep in-house, we'll keep in-house. Purely practical decision making.
We have time for another question? Then perhaps it'll be my question. This is somewhat following on from Tom's question about APIs. Do you see opportunities for standardization of any of the APIs, or is that not really an issue? Are you happy with just anything that's, say, RESTful English JSON?
I was thinking about that question, and APIs are going to change. I think we have to accept the fact that APIs are not going to be standard. There might be standard sort of ways of communicating, but it's a lot easier for us to work out how APIs are changing than it is to try and understand a whole new system. So if we switch out a new system, it's got a different API, we should be able to learn that pretty quickly. Does that answer your question, or is that your question something slightly different?
No, I think that was it.
That's good.
Thank you very much.
Yeah.